This lesson is titled Intro to Statistics Part 1. In this lesson, we're really going to understand the measures of central tendency, or rather learn to calculate mean, median, and mode, and we'll also talk about the range and the outlier of a data set as well. So to kind of get us started, there's a quote by Mark Twain that says there's lies, damned lies, in statistics. And what this quote is really referring to is the persuasive power of numbers, or how powerful numbers presented in a given context or in a given scenario can be to persuade us or to make us feel a certain way. Another reason that I guess this lesson is important, not only because it's in a curriculum, but we're living in a world, a very quantitative world. So a lot of what we're seeing in the media is numbers and statistics, particularly related to COVID-19. So it's important that we understand where these numbers are coming from, how people are coming up with them, and how to digest them and take them in. And so in this lesson, we're going to be talking about calculating certain values, mean, median, and mode, and then in another section, we're going to talk about data displays, which are also highly important as well. Okay, so to get started, measures of central tendency. So there's three that we're going to talk about in this class, and these typically describe the middle of the data set. So first we have the mean, which is the average. And to calculate the average, you add up all of the items and divide it by how many items there are total in the data set. The median is the middle number, so right in the center. And in order to calculate the median, it's important to write the number smallest to biggest. Okay, so when we're talking about the median, we're talking about once the numbers are in order, not necessarily just the middle of the data set you're given, because the numbers are typically out of order. And the mode is the number that occurs most often. You can have data sets that are bimodal. Bi means two, like a bicycle has two wheels. So bimodal means two modes. Trimodal, tricycle has three wheels, tri meaning three, so three modes. So one of the ways to remember this is that in order, this refers to average, middle, and most. So those are maybe some one-word terms that you can use to define these measures of central tendency. There's a couple of other ways to describe data that we'll talk about before we get into our examples. So another way to describe data is the range, which refers to the span of the data set. So in order to calculate the range, you take the biggest value of the data set and subtract the smallest value from the data set. An outlier are numbers that stand out or that kind of maybe look like they don't belong in the data set. So example 1a. So we're going to use this data set for 4 parts, and we'll calculate mean, and median, mode, and the range. So given the data set, 118, 94, 84, 90, 78, 87, 90, 113, and 84, find the mean of the data set. Okay, so the mean, or the average, is calculated by adding up all of the numbers in the data set. So we would take 118 plus 94 plus 84 plus 90 plus 78 plus 87 plus 90 plus 113 plus 84. So that would be in the numerator. The denominator is how many items there are in the data set. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would perform this calculation in your calculator. I recommend getting the numerator, pressing enter, writing down that number, and then dividing it by the denominator. I would also recommend plugging this into your calculator a couple times. It's really easy to mistype a number. And so with that, you want to do it a couple times to check and double check your work. But also in any work that you submit to me, make sure something like this is written, because if I know what you're doing and can conclude, oh, maybe it was a calculator typo, that would help me know that you're understanding it. Okay, so if you plug this into your calculator, if you want to plug it in all at once, you would need to put parentheses around the entire numerator and then divide by the denominator. So for this problem, we would get 838 divided by 9, and then rounded to the nearest tenths place. Our average of this data set would be 93.1. Next, calculate the median of the data set. And so in order to calculate the median, you want to write your numbers smallest to biggest. So what I do is I typically look for the smallest number first, cross it off as I write it down, and then keep going up. So 78 is our smallest. I'm probably going to write it down here. And then 84, and we've got 2 of those. And then the next is 87, looking at my notes to make sure I get these right the first time for you. 90, and we have another 90, and then we have 94, and then we have 113, and then we have 118. The other thing I do as well is I calculate, so I started with 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 numbers here. I'm going to make sure that when I rewrite my numbers, smallest to biggest, that I also have 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the median is the middle of the data set. So what I'm going to do is usually I'd show you on an overhead and I'd just kind of go through and block out numbers with my fingers as we go, but I'm going to cross them off in green and show you how I get to the middle. So these 2 are gone, these 2 are gone, these 2 are gone, and pretend that they're going at the same time. These 2 are gone, and so I'm left with 90. So 90 is my median. It's in the middle of the data. Okay, we'll talk about in another example what to do if you end up with 2 numbers in the middle. Okay. So 90 is the median. Next, we're going to talk about the mode. It's also helpful to get the mode from the numbers written smallest to biggest. And remember that mode means most often. And it's there could be 1, 2, 3, 4. There could be a different number of modes in the data set. So in this case, there's 2 numbers that occur most often, and I'll circle them in red. 84 occurs twice and 90 occurs twice, which means that our modes are 84 and 90. It's both of them. One isn't necessarily more important than the other. There's 2 modes. They both occur twice. Lastly, calculate the range of the data set. Again, this is helpful to do when you have the numbers written smallest to largest. So in this case, we would have 118 minus 78. So in this case, if we subtract these 2 numbers, we would get 40. So the range is 40, meaning that's the span of the entire data set. Okay. In the next example, we're going to talk about the differences between mean and median and why one might be better to use over another and how outliers affect those. So we have a data set. So let's say in the room there are people with the following ages: 2, 4, 5, 8, 16, and 72. Okay, so maybe a grandparent with their grandchildren. So if we find the mean of this data set, we would add up 2 plus 4 plus 5 plus 8 plus 16 plus 72 and divide it by 1, 2, 3, 4, 5, 6 and divide by 6. So if we do this calculation, we should come up with 17.83. So because it's maybe a grandparent with their grandchildren in the room, this average is being pulled towards 72 because that's a higher number. Okay, so let's talk about the median of this data set. The median in this case would be between 5 and 8, which would give us 6.5 about. Okay, so notice that these 2 are very different. The average is much higher. The median is about 6.5. So what is going on here? In this case, this is a demonstration that the mean or the average of a data set is impacted by outliers. So in this case, 72 is an outlier. It's a number that's kind of away from all of the other numbers if you were to visualize this on a graph or on a number line. And because that number is so much higher, it's pulling the average towards that number. However, median is just the middle of the data set and it is not affected by outliers. So sometimes the median is a better number to use than the average depending on what you're getting at. So I'll show you an example. So I found this to be really interesting. So one of the things I'm interested in is assessments and how you all are doing, if the test I gave was fair, so on and so forth. And so when I calculate test grades, these are not from this class, by the way, I look at the average and the median to determine how the test went. So in this class, the average was a 76, so about a C, but the median was a 91. What the median means, and it's right here drawn visually, is that half of my students got a 91 or higher. So median cuts the data set in half. So half of my students got A's on this exam. The other half got below an A, below a 91, but the average is 76. So as an instructor, I had to ask myself, was this test fair? Was it a good test? Was it a bad test? Was it too easy or was it just right? There may or may not be right or wrong answers to that question, but looking at the differences between the average and the mean was really insightful in this type of problem. And as you can see, most of the numbers are crowded around the AB range, so we've got some outliers there down at the bottom of the data set. Okay? So that's just a practical real-world example talking about the differences between median and mean. Okay? So let's kind of put all of this together. So the number of points scored by the Golden Knights in the last 8 games are shown below. Find the mean, median, mode, and range of the listed numbers. So again, we'll write our numbers in smallest to biggest. So typically I do that first just because I know once they're in order, I can get everything else that I need. So we have 0, 0. Okay, zeros count. Those were 0 points scored. They are part of the data set, so those have to count. So they count in all of our computations. Okay, 0, 0, 1, 1, 2, 2, and 3, 3. So for the average in this case, we'll take all our numbers and add them up. 0 plus 0 plus 1 plus 1. Now when you're counting the total number of items, again, these zeros count. 1, 2, 3, 4, 5, 6, 7, 8. And then we divide by 8. So if you do this, I believe you get 6, 7, 8, 9, 10, 11, 12. 12 divided by 8 should be 1.5. Okay, so the average or the mean in this case is 1.5. The median is the middle number. So again, we'll do our crossing off to come to the middle. 0, 3 are gone. So we've got 2 numbers in the middle here. So the middle here is actually in between 1 and 2. So what's in between 1 and 2? 1.5. Or what you can do is you'll take those 2 numbers in the middle and calculate the average of those 2 numbers. Essentially add them up, divide by 2, which gives us 1.5. The mode is the number that occurs most often, but in this case, it's almost every number of the data set. Okay, so this data set has 4 modes, and the range is the span of the data set. So 3 minus 0, biggest minus smallest, would give us 3. So we'll continue talking about more introductory information to statistics in the next lesson. Thank you for watching. If you have any questions, please feel free to reach out to me.